Good morning, everyone. So today we are going to be going over the very last section that we have here in Chapter 5. Yesterday or earlier this week, we talked about graphing these linear inequalities. And now in 5.7, we're going to be graphing what we call a system of linear inequalities. All right. So a system of linear inequalities, it's two or more linear inequalities in the same variable. So we are really not going to deal with more than two. We're just going to have two at a time. All right. So what that means, essentially just the Cliff's Notes version of everything we're doing today, we're going to have a linear inequality. Okay. We're going to test a point. Awesome. We're going to see where we shade it in. Okay, then we're going to have another linear inequality. Let's make this a dashed line. And then we're going to test a point on that one, and we're going to see, okay, where are we going to shade this one in? It's going to be on this side. You're seeing where those two shaded portions overlap. Okay, and we'll say that's our solution. I'll get way into more detail, but that's kind of the gist of what we're doing today. We're doing two different systems. We're seeing, which of these, see how there's kind of, 1, 2, 3, 4 different little quadrants here. You're seeing which of those four have our solutions. We're going to mark it with an S, right? So what we're used to, what we have done in the past is just a system of linear equations where it's just an ordered pair, right? But a solution of this is another ordered pair. There's an infinite number of ordered pairs. So, okay, a solution is going to be an ordered pair that makes all of your inequalities true, that makes both of them true. Okay, you're not just thinking about one or the other. We're trying to find the quarter of your graph that makes everything true. Okay, so the graph of this system of linear inequalities, it's the graph of all of the solutions in this system. All right. So we can check that if something is a solution of these. I'm going to be honest, I think it's easier if we just graph one, check the point on that inequality. Graph another one, check the point on that inequality, rather than identifying the four different sections and then testing a point on each of those four. I think that's super tedious. So I'm going to actually skip this checking solutions bit. Let's just get right into the graphing. Okay, we can kind of see same idea of what I drew my little sketch of before. You're graphing one inequality. Let's say we graphed this blue one here. Okay. All right, same process as always. Okay, this is in slope-intercept form, so my intercept is there. My slope is 1, so okay, awesome. I've got my little inequality. They must have tested the point 0, 0, and it must have been true, see, because we can see that they shaded all the way over in here. Same thing with this line. They drew our line. This one is a solid line. And they must have tested the point 0, 0, and that must have also worked for this inequality. Okay, so they shaded this whole area, everything to this side, and they saw, okay, this is where those two things overlap. Okay, we can see this little portion in here. Okay, this is only one. Okay, this portion over here, this is only one of our inequalities. This quarter in here where I drew my little S, that's where both inequalities are true. That's what we're looking for. I need you to identify, and I usually draw the little S. I need you to identify which of these, 1, 2, 3, 4, which of those sections have the solution for both inequalities. Okay. Usually when we start doing this, people like to use like colored pencils or crayons or markers, something where you can see where these two things are overlapping. Okay, something where you can visualize like the two colors, right? So do that if you have it. Okay, so details of graphing a system of inequalities. So you're doing each line individually, just like we've done before. Okay, you're deciding solid or dashed line, just like we did before. Okay, so solid is going to be anything with an or equal to included. Dashed is anything that's just greater than, less than. Okay, which side to shade? You want to test that 0, 0 point, as long as it's not going through 0, 0. And then darken in the area that was shaded for every line. So the portion that is true for both, you can either shade it super dark so you can see this is the part that I'm saying is a solution for both, or we can mark it with an S. Different teachers do it different ways. As long as it's obvious which of those 4 sections is your solution, it's fine with me. Okay. The solution is where it's shaded for every line, where all the colors look, so the common shaded area. So basically, where is it shaded for both? Okay, let's go through. Let's do this first one. Y is less than or equal to 3. That'll be our pink one. And then our blue one, let's do that y is greater than x plus 2. All right, so y is less than or equal to 3. First off, I know that that is going to be a solid line. Oh, I wanted pink. Solid line. Okay, because it's less than or equal to. And I also know that anything that's just y is equal to or y is less than, a number, I know is just going to be a horizontal line at that number. Okay, so y is less than or equal to 3, and I know I've got a solid line. Doing my best here with the line. All right. Draw my little arrows. So I'm going to shade this one before I see the next one, because I think the more lines, the more stuff you have on your graph at a time, the harder it is to kind of visualize where you're supposed to shade. So I'm going to shade this one first. Okay, I'm going to test the point 0, 0. I'm going to say, okay, does that work? Okay, so y is less than or equal to 3. Okay, let's test the point 0, 0. So, okay, so now I have 0 for y is 0 less than 3. It is. So we're going to shade in that part. We're going to shade in that part that includes our little 0, 0. So everything below this line is getting shaded in. All right. Now let's do our little y is greater than x plus 2. I'm going to do this one in blue. Okay, awesome. This one's already in slope-intercept form, so it's a little bit easier when you don't have to rearrange everything. Okay, we can see our y-intercept is 2, so that's my starting point. My slope here, I've got an invisible 1, so I can think of that as 1 over 1, so up 1 and over 1. Okay, up 1 over 1. I draw a couple points. Again, I'm going to do the best I can on this line. I should have thought before I did anything else, solid or dashed, and I would have thought dashed because it is just greater than, it's not, or equal to. Okay, so I'm going to draw my little dashed line over here. Again, remember I'm doing this on my computer screen, so it might not be perfect. All right, that was actually pretty close. Okay, draw my little arrows. So I've got my line, and now I need to do my test point. Okay, so I know I'm going to test 0, 0. Okay, I can see right here. Am I going to shade this part down below or this part up above? Okay, so 0 is greater than 0 plus 2. So is 0 greater than 2? No, right? 0 is not greater than 2. So I'm going to shade the part that doesn't have that test point. And the mistake people make sometimes is they think they're only shading like this part of the line. You want to make sure you're shading the whole thing, okay? Everything that's on the side you want, okay? We want the part that doesn't have 0, 0. So we're shading this whole area, okay? Just be careful with that because it's kind of easy to just think you're shading like one small section. It's this whole half of your line. All right, and this is why I like to do 2 colors, because that makes it a lot easier to see where those 2 things intersect. Okay, we can kind of think of this like I've got, 1, 2, 3, 4 sections that these 2 lines make. I'm deciding which of those 4 sections is my solution. Okay, and it's this part right here, right, where I have blue and pink together. Okay, so I can either mark it with an S, or what some people like to do, let's see if I've got a darker color. Okay, what some people like to do, here we go, is they like to basically shade in that part that has both super dark. Okay, so either one of those is fine. Shading in this part super dark so I can see obviously this is the part, or you can mark it with a little S, kind of whatever you prefer. Okay, I do both. All right, so let's move on. Let's see. Let me make sure there aren't any other. Let's do this nice slope intercept form one right here, this problem C, okay? Sort of a similar one to the one we just did, just so we can see the process again. All right, so I've got my y is greater than or equal to -1. Okay, I know that's going to be a solid line. Okay, I'll do the same thing where I do the first one in pink, I'll do the second one in blue. I know that second one's going to be a dash line. I'm going to do that right away so I don't forget. That's one of the easiest things to forget because there's so many things that you're thinking about. Okay, that dash line, solid line stuff. Okay, just don't forget to do that as you're thinking about your lines. Okay, y is greater than or equal to -1. Well, I know that that is just going to be a horizontal line at -1. Okay, so I know that's a solid line there at -1. Okay, I'm going to draw my little arrows. And I want to see, okay, which side of this line am I going to shade? Am I going to do the part with 0, 0 or not? Okay, so I'm going to plug in 0 for y. Okay, is 0 greater than or equal to -1? Well, 0 is always greater than a negative number, so yes. All right, so this part with 0, 0 is getting shaded. Okay, this whole thing. A lot of times when people mess up the systems of equations, they usually mess up because they will shade like half of the line instead of the whole line. Okay, and then let's get to this y. Y is less than this -x plus 2. Okay, so 2 is our y-intercept. I've got a slope of -1, so I like to think of that as -1 over 1. So down 1 and over 1. Down 1 and right 1. Okay, don't let the negative slopes mess us up. I see a lot of us messing up those negative slopes. Okay, you're going down, but still right, not left. Right. So I'm going to make my dash line here. Okay, with my little arrows. Make sure you make those lines go pretty much the whole length of your graph, because if they don't intersect, it's going to be hard to see where those two bits of shading overlap. Okay, same deal. I want to see, am I going to shade, above my dash line here or below? Okay, so I'm going to test my 0, 0 point. I'm going to have 0 is less than 0 plus 2. So is 0 less than 2? Yes, 0 is less than 2. Okay, so my little test point, that 0, 0, that's the side I'm going to shade. Okay, and here's where people sometimes kind of mess up. They think, okay, I'm shading this part, and they stop when they have a line. You're going to cross that other line. You don't care about it. Okay, you're shading the entire underside of this other line. Don't stop when you see the other line from your other inequality. You don't care about it. Okay, because if you're going to see where these lines overlap, you've got to make sure that you shade this entire half of your graph. Okay, again, we should see where these two things overlap, where they intersect. I'm just going to draw my little S. Okay, S for solution, right? Okay, we can see which of these where both of my solutions kind of overlap. All right. And then I'm not sure if there's a no solution problem in your homework. I'm going to show you real quick what that looks like. And we get to practice changing from standard form to slope-intercept form. Okay, awesome. So 2x plus y is less than -1. I'll make that a little pink inequality. And then 2x plus y is greater than 3. All right, so first off, we know that both of these, neither of them have an or equal to, so they're both going to be dashed lines. I just want to think of that before anything else, otherwise it's super easy to forget. And then I want to take each one and I'm going to change that into slope-intercept form. So let's start here with 2x plus y less than -1. All right, I want this in slope-intercept form. I want that y on its own, so I'm going to move that 2x over. I'm going to subtract it. So I end up here with y is less than -2x minus 1. And then we're going to graph it. Actually, I'm not going to do the blue one first. I'm just going to graph the pink one here while we have it. Okay, y is less than -2x minus 1. Okay, so that's my y-intercept, -1. And my slope is -2. So I like to think -2 over 1. Down 2, right 1. Okay, so down 1, 2, right 1. Same thing, down 2 and right 1. I'm going to draw my little dash line here. Okay, and then I'm going to use my test point. Okay, 0, 0, what are we thinking? Is it going to be true or not true? Okay, 2 times 0 plus 0 less than -1. Okay, so is 0 less than -1? Okay, well, 0 is not going to be less than a negative number. So no. So we're going to go in. We're not going to shade the part with 0, 0. We're going to shade the part without 0, 0. Okay, so all along this line. Okay. Now let's do the same with our other equation, or inequality. I always say equation, even if I mean inequality. Okay, 2x plus y greater than 3. Okay, so same deal. Let's get rid of that 2x. So I'm just left here. I got y is greater than -2x plus 3. So, okay, I've got my y-intercept here at 3. I've got the same slope, -2. So down 2 and over 1. Okay, down 2 over 1. I'm going to draw my little dash line here in just a second. Trying to be pretty precise with this. All right. Pretty close. I know that looks like they're not exactly parallel, but they're supposed to be parallel. It's as close as I can get when I'm drawing on my laptop. All right. So we see that these lines are not intersecting. All right. Well, let's see what happens when we plug in our test point. Let's plug in 0, 0. Okay. Are we going to shade this part that has 0, 0 or our other side? Okay. So 0 greater than -2 times 0 plus 3. Okay, so is 0 greater than 3? 0 is not greater than a positive number, so that's not true. I'm going to shade over here on the other side. Okay, I'm shading over here. And there's no solution, right? There's nothing that overlaps. There's no part where both of my lines have a solution. I know in my lines it kind of looks like if I zoomed out, they would eventually intersect, but that's just because I drew a little sloppy, okay? These are parallel. They're supposed to be parallel. They're not going to intersect. There's not any part of this whole graph that both of these inequalities are true, okay? So that's what we mean when we say we have no solution, okay? So we could do the same as we always do. You could just write out to the side, no solution. Either of those work. I don't remember off the top of your head of my head if your homework has any like this, but if you see it, now you know that that's just a no solution problem. All right, make sure you get that homework done. I've got it posted. Remember that our Chapter 5 test is either Monday or Tuesday, depending on if you're A day or B day. I have that practice test posted as well. Make sure you're going through that. And then hopefully we all do well on that next week. I'll see you guys later.